Hi, my name is Kalyan T. Valsaraj and this is my YouTube channel. This video is about my research and the connection between my photography pursuits. In the course of more than 40 years of academic research, I have focused on the transport and transformation of anthropogenic chemicals released into various environmental compartments, including air, water, soil, sediments, and biota. This field, known as environmental chemodynamics, is crucial for the understanding of the fate and movement of diverse anthropogenic chemicals. My work has centered on tracing the pathways of these chemicals to their receptors across different environmental media. While humans are the ultimate receptors, most chemicals bioaccumulate in various matrices before reaching humans through ingestion or contact, either intentionally or inadvertently. Apex predators, particularly avian species, serve as sentinel organisms in this context. More than 6 decades ago, Rachel Carson's seminal book, Silent Spring, highlighted the detrimental effects of persistent organic pollutants. She drew attention to the reproductive harm caused by DDT to eagles and ospreys which suffered from consuming contaminated fish and rodents. This revelation led to a significant environmental movement, culminating in the ban of DDT for pest control, resulting in the recovery of these bird populations. Nonetheless, other chemicals that act as endocrine disruptors remain in use, adversely affecting numerous apex predators through exposure to contaminated prey such as rats and mice. Many pesticides, rodenticides, and pharmaceutical products are lipophilic, accumulating in the lipids of fish and small mammals, which then transfer these chemicals to larger predators through a process known as bioaccumulation. These substances can disrupt endocrine function and exhibit toxicity in predatory birds. While my research has investigated pollutant concentrations and exposure rates among these predators, it has not delved into the specific effects on apex predators, an area outside of my expertise. This video aims to connect my work in environmental chemodynamics with ongoing research into these endpoint impacts. Avian apex predators serve as effective indicators of the harmful effects of bioaccumulation. Eagles, ospreys, and hawks typically hunt fish and small animals during daylight hours, while nocturnal predators like owls depend on mice and other mammals that are also active at night. These rodents are often treated with rodenticides, which can introduce various anthropogenic chemicals into the food chain. Owls, which inhabit every continent except Antarctica, are a unique subset of nighttime avian predators. Despite cultural associations with bad omens, they play a vital role in ecosystems by preying on nocturnal pesticides like pests like mice, voles, small mammals, and snakes. Classified under the orders Trigiformes, owls are divided into barn owls, Titonidae, and typical owls, Stringidae. Approximately 254 to 268 owl species exist globally with wide distributions. Owls thrive in diverse habitats, from tundra to tropical forests, grasslands, and deserts. As apex predators, they face potential population declines due to several factors, including habitat destruction, climate change, the pet trade, and the use of chemical pesticides and rodenticides. Owls primarily consume rodents that may be poisoned, leading to secondary poisoning, a significant concern. Chemicals such as organophosphates, carbamates, and anticoagulant rodenticides are major culprits. Additionally, the decline in prey populations due to pesticide use may lead to starvation among owls. In many regions, agricultural pesticides and rodenticides are applied near owl nesting sites. Anticoagulant rodenticides can cause internal bleeding and mortality in apex predators. Despite the ban on chlorinated pesticides like DDT in the 1970s, their persistence in soils and waters continues to cause reproductive issues such as eggshell thinning and embryonic loss. Neonicotinoid pesticides also adversely impact insectivorous bird populations, creating cascading effects on owls that rely on these species for food. In North America, a significant study conducted by the American Bird Conservancy has assessed the status of owl populations across 14 different species. In many areas of the US, the barred owl population has remained stable and is even increasing, leading to habitat management efforts aimed at controlling their population in the western US to protect smaller owl species. Conversely, eastern screech owls and northern spotted owls are experiencing declines due to habitat loss and competition with barred owls for nesting sites. Eastern screech owls, which typically nest in cavities close to human habitation, are particularly vulnerable to eviction by the larger barred owls in forested areas. The snowy owl has also seen a dramatic decline, over 60%, attributed to habitat destruction and climate change. Barn owls, which commonly inhabit agricultural landscapes and help control pest populations, are facing reductions in numbers due to habitat loss and exposure to rodenticides, leading to eggshell thinning and reduced nesting survival. In the Indian subcontinent, 70 owl species have been documented, but overall populations are declining due to habitat destruction, illegal pet trade, and widespread use of agricultural pesticides, rodenticides, and insecticides. While habitat loss is challenging to mitigate, the use of rodenticides and secondary poison can be addressed. Despite understanding the toxicity of organophosphate insecticides, example fenthion, chlorpyrifos, and FAM4, they continue to be applied in parts of India. Anticoagulant rodenticides are also used by farmers, leading to the poisoning of rodents that serve as prey for barn owls. In certain regions, such as the remote Lakshadweep Islands, biological rodent control using owls has proven effective, highlighting the inadequacy of chemical methods. Although organochlorine pesticides are no longer in use, their persistence from earlier applications continues to impact reproductive success in owls. Carbofuran, a carbamate pesticide, is another factor contributing to the decline of owl populations. The brown bubuk, known as the brown hawk owl, is found in southern India, Sri Lanka, and many other Asian countries. Although not yet listed as vulnerable, their population has declined by more than 20% in the past 2 decades. It primarily preys on rodents and other small animals susceptible to rodenticide exposure. Its habitat is being continuously destroyed due to human encroachment. The oriental scops owl, a widespread species in South Asia, is classified as least concern by the IUCN. However, local habitat destruction for human development poses significant threats to its population, and high rates of rodenticide use not only diminish its food sources but also lead to reproductive challenges. The mottled wood owl, commonly found in gardens and wooded areas primarily in India and Nepal, preys on rodents and small birds exposed to rodenticides. Although not currently threatened, there are growing concerns regarding habitat loss and potential reproductive issues. It has been shown to have a declining population around 19% all over India. The declining owl population throughout South America is primarily attributed to various threats, notably habitat loss and the application of rodenticides. This issue spans across all regions, from the Atlantic forests of Brazil to the grasslands of Argentina. Additionally, climate change is intensifying these challenges. Of the 22 species in South America, 6 are categorized as vulnerable or endangered. A few of the common owl species often found in South America include the great horned owl, tropical screech owl, Central American pygmy owl, and ferruginous pygmy owl. The ferruginous pygmy owl populations are experiencing declines in certain regions of North America, primarily due to habitat loss linked to agriculture and climate change. In contrast, there is a slow overall population decline, about 10%, throughout South America. Nevertheless, these populations remain susceptible to habitat degradation, agricultural pesticide use, and occasionally kept as caged pets. Concerns regarding the decline of pygmy owl populations in South America largely center on the ferruginous pygmy owl, which is widely distributed across Central and South America. Although it is typically regarded as a common species, certain populations are encountering threats and experiencing reductions in numbers. In contrast, the Pernambuco pygmy owl, recognized as a separate species, is classified as critically endangered and possibly extinct by the IUCN. Additionally, the cloud forest pygmy owl is facing population declines attributed to habitat loss and degradation. The tropical screech owl is classified as a species of least concern by IUCN. However, its population is experiencing a downward trend due to throughout its extensive range in South America. Although this decline does not occur at a pace sufficient to categorize the species as vulnerable, various factors are adversely affecting its numbers. Key contributors to this population decrease include deforestation, clearing of forests for agricultural expansion, urban development, and resource extraction. While tropical screech owls prefer habitats at the edges of forests and in open woodlands, significant forest loss detrimentally affects their living conditions. Additionally, as insectivores, these owls are susceptible to the effects of pesticides used in agricultural zones and plantations. Such chemicals can directly harm the owls or diminish their food sources, further exacerbating their population challenges. Current data does not indicate a significant decline in the great horned owl population in South America. This species is classified as least concern globally and seems to be stable in many regions. In contrast, populations in North America, especially in the US and Canada, have experienced reductions due to pesticide application, habitat destruction, and vehicle collisions. However, the great horned owl's ability to adapt to various environments and its extensive geographical range have enabled it to prosper across much of the Americas, including South America. Extensive literature exists on the role of wildlife toxicology in owls as biomonitors of environmental contamination. As apex predators primarily preying on nocturnal rodents, exposure to rodenticides poses a significant risk to owls worldwide. The primary pathways of exposure and mortality include secondary poisoning and bioaccumulation. Documented effects such as eggshell thinning and impaired reproductive capabilities indicate a direct correlation between declining owl populations and the increased use of pesticides and rodenticides. Since the mid-1900s, when pesticide use became prevalent globally, owl species have been seeing gradual population decline. Systematic monitoring of diseased owls for pesticide residue analysis can serve as an early warning system for harmful anthropogenic chemicals in the environment. Continued photographic documentation of owls worldwide will significantly contribute to conservation efforts, a pursuit I intend to support through my photography. Currently, I have observed roughly 4% of the owl species worldwide. My goal is to explore and study as many as possible in the coming years, particularly focusing on those that are especially susceptible to human-made chemicals. So subscribe for watching, and if you haven't subscribed yet, please hit the subscribe button so that I can bring you more of these interesting videos in the future. Thank you.